testing. And a hypothesis is nothing more than an educated guess, okay, in a nutshell. And as far as hypothesis testing, you can never accept the hypothesis, which sounds kind of crazy. You can only reject it or you can fail to reject. Okay. There is a quote by Mark Twain. And this is the quote that he says. There are three kind of lies. There are lies, there are damn lies, and then there's statistics. All right. So with that being said, as far as a hypothesis is concerned, it's basically an educated guess. One thing about a hypothesis is that you can never accept. You can only do two things: fail to reject it and reject it. Okay, those things are totally different than actually saying, okay, this is true, we're going to accept it. Okay. So as far as hypothesis tests are concerned, and as far as your calculator is concerned, we're going to look at two types of hypothesis tests. And these hypothesis tests are located within the stat. And if we scroll over to test, we're going to use, I think it's three kind of tests we're going to use. We're going to use the two-sample t-test and the one-sample t-test. Okay, where is it? Or did I pass it? Well, I'm sorry, a one-sample t-test is basically a t-test. Let me just get my bearings straight on this. All right, so we're going to use this t-test. The reason why we use a t-test and not a z-test is because for a t-test, the population standard deviation is unknown. And as we kind of talked about, whenever you're talking about a population statistic, which is a parameter, it's impossible to get a parameter, right, from a population, because it's hard to get information from every single person in that population. So instead of using the t-test or the z-test for means, we use the t-test. We're also going to use this two-sample t-test. When we talk about proportions, so remember, a proportion is basically a fraction where you have the part over the whole. When we test for those proportions, for our purposes, we're going to use this one prop t-test, z-test. Okay, so these are the three things we're going to use to test for hypothesis. Right, so when you're testing for hypothesis, we base the either reject or fail to reject on this criteria called a p-value. So the calculator is going to give us the p-value. We simply put in all the given information or all the given statistics. It's going to give us a test statistic. It's also going to give us a p-value. In each one of our problems, we're going to be given a significance level called alpha, right? So alpha, that is the significance level and that'll be given in a problem. Okay. Based on the significance level and the p-value, we make these determinations. So if we have a low p-value, so that means that the p-value is lower or smaller than the significance level, we reject the null hypothesis. Okay, we're going to reject that educated guess. Okay. And these are the conclusions. So this would be the conclusion. Right? So if you had a low p-value, if your p-value was lower than your significance level, you will reject the hypothesis, and this would be your conclusion. There is enough evidence to support the alternative hypothesis. So just some terminologies. HO, whenever you see that, that's the null hypothesis. And HA is the alternative hypothesis. Okay. Now, for our purposes, whenever you're asked to write out your null hypothesis, we're always going to use the equal, right? So we're going to see an example of that in a second. But you're going to notice as you go through some of the problems, when they give you the null hypothesis, they may not always use equal. Okay, so that's just one thing. Whenever you're asked to write out any null hypothesis, you're always going to use the equal. Okay. And then in the question, the alternative hypothesis will be less than, greater than, and so on. But the main null hypothesis is equal. Okay. So now there's a saying about a low p-value. It says if the p-value is low, then the null hypothesis must go. Okay. And I didn't make this up or anything. All right, so if you have a low p-value, you're going to reject the null hypothesis, and your conclusion should be there is enough evidence to support the null hypothesis. Okay, so you're not really accepting anything. Okay. So now that's for a low p-value. If you have a high p-value, that means that if your p-value is larger than your significance level, then you fail to reject the null hypothesis, and your conclusion says that there is enough evidence, or excuse me, there is not enough evidence to support the alternative hypothesis. Right. So when it asks you for the conclusions, there either is going to be enough evidence to support the alternative hypothesis, and for the purposes of this conclusion, sometimes they may actually write out that alternative hypothesis. Okay, and we'll see that how that plays out in a minute. And then if you have a high p-value, you fail to reject the null hypothesis, your conclusion is that there is not enough evidence to support the null hypothesis. All right, so in a nutshell, these are just the key ingredients, right? You're going to be given a significance level in your problem. You have to compare the significance level in your problem with the p-value, then you can make your decision on whether to reject the null hypothesis or fail to reject it. Okay. All right, so let's take a look at the test review. Now, as far as the test review is concerned, the first couple of problems, I believe, they deal with, the very first problem, it deals with a confidence interval. Okay, so we're going to take a look at number one. Okay. We're going to revisit that. Okay, but we're going to start with 2 through 5, and then we're going to come back, kind of dovetail back to number 1. All right, so this is problem number 2. So just remember, as we go through this, if it says mean or average, we're either going to use that t-test or the 2 sample means. If you're given a proportion, right, like a part over whole, we're going to use that one prop z-test. Okay. So now this one reads that the effectiveness of a blood pressure drug is being investigated. An experimenter finds that on average, so that's another word for the mean. On average, the reduction in systolic blood pressure is 74.8. The sample size is 769, and the standard deviation is 8.8. Estimate how much, oh, I'm sorry, this is a confidence interval too. Okay, so we'll just start with this one. Okay. So it says estimate how much of a drug will lower a typical patient's systolic blood pressure using a 98% confidence level. All right, it says enter your answer as a trilinear inequality. So notice that they kind of give us the hint that this thing is a mean. Okay. So now this is a confidence interval. This is a confidence interval of the mean. So for this problem, okay, I'm going to go back to the beginning. I'm going to go into stat. I'm going to scroll over to test. I'm going to scroll down to T interval. Right. The reason why we're using a T interval versus a Z interval, first of all, we're talking about a mean. Second off, we are given the standard deviation of the sample, which means that the standard deviation of the population is unknown. So we use stat. We went over the test, and we're using the T interval. All right, so I'm going to hit enter. So now for the input, there's 2 types of input. You can actually put in the data if you have a data set. Since we have the statistics, right, we know the mean, the standard deviation, and the sample size, I'm going to scroll over to stat for the stats we're going to put in. Okay. So we're going to use stats, and we're simply going to put in the stats. So X bar, remember that's the mean. And if we go back to our problem, it says that on average, the reduction in systolic blood pressure is 74.8. So our mean is going to be 74.8. We have to put in S of X, which is the standard deviation of the sample. So we're given that standard deviation is 8.8. We also have to put in N. So remember that N is the sample size. And our sample size is 769. We have to put in a confidence level. So here we're choosing a 98% confidence level. And we're going to calculate. So does it tell us how to round? It doesn't really say which, accurate to 1 decimal place. So we have our confidence level. It's going to be 74.1 to 75.5. So 74.1, the mean, right, is in between a 98% confidence interval of 74.1 to 75.5. All right, so here we use a T interval.
How would I do it on the T1?
This. I brought mine just because there is a difference. So you still go to stat, test, T interval number 8. This one like looks the same. Okay, go over to stat. And now hit enter. And then it changes it. Right. So you must hit statistics because data, if you were given like a data set, you would put the data set in, and then what the calculator would do is it would calculate the mean, it'll calculate the standard deviation, it'll calculate the sample size. But if you're given those statistics, you just want to make sure once you go into the T interval, right, that you choose statistics because it may be set on like data and you may be looking at something totally different. All right, that was number 2. So let's go back to number 1 and then we'll take a look at the hypothesis test. All right, so this is number 1. So just notice in the problem, we see this little notation. This denotes a confidence interval. Okay. And they're giving us P in the middle. So this would be a proportion. So as we read through the problem, it says out of 300 people sampled, so 300 people would be our total, 60 preferred candidate A. So the part that preferred candidate A was 60. It says round to 3 decimal places. Based on this estimate, what proportion, and they want you to write that out as a decimal, of the voting population prefers candidate A? All right. So now on this actual problem, there's actually 2 questions. There's an A and a B. So it's not really like print friendly as you go in and it kind of guides you through the answer. So it wants the voting population that prefers candidate A, right? So the proportion of the voting population that prefers candidate A, and I'm simply going to make a fraction. The part of people that prefer candidate A is 60 divided by all of the people in the sample, which is 300. So 60 divided by 300, that should give us the voting population that prefers candidate A, right? And it wants the answer as a decimal. So here we have 0.2, which is 20%, right? But they want us to express that specifically as a decimal. Now B, right, that's A and this is B. So B says compute a 90% confidence interval and give your answers to 3 decimal places. So we're trying to find a confidence interval for a proportion. So I'm going to go into stat. I'm going to go over to test. I'm going to go down to 1 proportion z-test. So now for means, we use the t-test. But for proportions, we use the z-test. So I'm going to lock that in with enter. And now I'm going to put in the statistics. All right, so we're given that. I'm sorry, I'm doing a. We want a z interval. No, a 1 proportion z interval. Let me just write that down. So we did stat, test, 1 proportion z interval. Okay, I'm thinking about hypothesis test. So, okay. So now if I click enter, it should ask for something a little bit different. It asks for X. So what is X? Well, X is going to be the number of successes, which is 60. N is the number of people sample. That's right, sample. That's equal to 300. So X is 60. N is 300. Our confidence level is 90%. And now if we hit enter, and it says 3 decimal places. So we have 0.162, comma 0.238. Right, so for problem number 1, well, I shouldn't really say your problem number 1 because I think it may like scattered around. But for that voting problem, you want to use a 1 proportion z interval. Right? For the mean confidence interval, you want to use that t interval. All right, now the rest of the problems, they deal with the hypothesis test. So let's look at problem number 3. So for 3, 4, and 5, we're going to use this set of criteria, right? We're going to base we're going to compare the p-value and the significance level, and we're going to make a determination about the null hypothesis.
When we're talking about the mean and when to use what.
Okay, when you're using a mean, you're going to use the t interval. Okay, and the reason why we don't use the mean with the z interval for the mean is the population standard deviation is not known. So for anything we do in this class, if you're finding a mean, anything with the mean, you're going to use that t interval or the t test, which you're going to take a look at. If you're dealing with a proportion, you'll use the Z, one proportion Z interval. Okay. So that's the difference. There is like no T for a proportion, but for the mean, you always want to use the T. Okay. All right, here is number 3. All right, and this is deal with the hypothesis test. So it says a shareholders group is lodging a protest against your company. The shareholders group claimed that the mean, so we're dealing with the mean, tenure for a CEO was less than 11 years. A survey of 93 companies reported on Wall Street Journal found that the sample mean tenure of 10.4 years for CEOs with a standard deviation of 4.9. The Wall Street Journal, from its issue January 2nd, 2007. You don't know the population standard deviation. All right, so this is what alludes to the T stuff. But we can assume that it's normally distributed. All right. So now it says you want to formulate a test. You want to formulate and test a hypothesis made by the group at the significance level of, and this is our significance level, 0.002. Your hypotheses are, so they give us the hypothesis in this problem, that the null hypothesis, right, this is that H of 0, that's the notation for null hypothesis, is that the mean is greater than or equal to 11, right? That was the claim, or the educated guess. The alternative hypothesis is that the mean is less than 11. So notice in this problem, they actually give us like 2 mean values. It says that the shareholders group claimed that the mean tenure for a chief executive officer was less than 11 years. That was the null hypothesis. But it said when you surveyed 93 companies, you found that the mean was 10.4. So notice they're giving us 2 means. This first mean is an educated guess, right? The second mean, they actually surveyed 93 companies and they found this mean from a sample. So keep that in mind, all right? They also found that the standard deviation from those 93 companies was 4.9. They did not know the population standard deviation, but it was normally distributed. So when you have to write out your null hypothesis, you're going to use the guess mean, not the actual mean that was found in the sample. Because when we put this stuff into our calculator, it's going to ask you like for those 2 means. Okay. So it says, what is the test statistic for the sample? What is the p-value? Is the p-value less than or equal to alpha? Is it greater than alpha? Do you never accept it? So would you reject the null hypothesis? Would you fail to reject? And then we have to write out the conclusion. So now, based on this setup, we're going to use a t-test. Okay. Use a t-test for the mean, right? So we're going to use, to be more specific, I'm going to go and just pull up your calculator. So I'm going to go to stats. I'm going to scroll over to test. And I'm going to use a t-test. Okay. So that was stats. I scrolled over to test. and we're going to use a t-test. This was the second. All right, that second option. So now once you click on t-test, it's the same thing. They're going to ask for the data. That's if you were given a data set. And then they ask for statistics. Now, since we were not given a data set, we were actually given the statistics, right? We were given the mean. We were given the standard deviation. We were given like the sample size. We're going to scroll over to stat and hit enter. Okay, now for our purposes, we're always going to use stats. Okay. So now that we have stats, they're asking for a few things. They want mu sub 0. They want x bar. They want us to put in the standard deviation. They also want n. And then we'll look at this last line in a second. What do you think mu sub 0 is? That's going to be the mean that was guessed. That's going to be the hypothesis, the hypothesized mean, the guess mean. That's 11. Okay. So that's going to be hypothesized mean, which is 11. What do you think x bar is going to be? Well, that's the average, 10.4. All right. Okay, what is S sub x? That's the standard deviation of the sample, which is 4.9. And what is N? 93. Now, for the last line, we're going to base this last line off of our null hypothesis, our alternative hypothesis. All right, so this last line depends upon this alternative hypothesis. So since the inequality in the alternative hypothesis is less than, I'm going to choose that less than option. So is everybody okay with that?
7, 8. Where do you find that?
You find that right here. Let's see. So that last line was mu, and we're going to use less than mu sub 0. That is from the alternative hypothesis. So never put in the one from the null hypothesis. It's always the alternative hypothesis. All right, so let me put all of this stuff into the calculator. So we're using the t-test, we're using statistics. Mu sub 0, again, that's the hypothesized mean, which was 11. X bar, that's the average from our sample, that's 10.4. S sub x is the sample standard deviation, which is 4.9. N, that's the sample size. We surveyed 93 companies. And we're going to use the less than inequality because we're basing that on the alternative hypothesis. And if we calculate, notice what they give us. They give us, it says mu is less than 11, so that's our alternative hypothesis. They give us the t-test statistic. So for problem, and it didn't do a real good job labeling this out, but this says, I'm going to just call this A. It says, what is the test statistic for the sample? The test statistic is negative 1.18. So I'm going to write that out. The test statistic T is equal to negative 1.18. All right, that's our test statistic. B says, what is the p-value? So we're given that this p-value, now this is the p-value, not a proportion or anything. So the p-value is rounded to 4 decimal places, 0.1203 or 1204. This is B. P-value equal to 0.1204. And if you look at the answer key, it kind of gives you two values. This was number 3. It says 0.1204 or 0.1203. Okay. Did anybody get anything other than one? And I rounded this because if I go out to 4 decimal places, I'm at 3. If I look one place to the right, since it's 5, I round that up. Okay, so did everybody get 0.1204? Because it's got 2 answers, and it did that for the other one too.
No, mine came out 0.87.
For the p-value?
Mm-hmm.
Okay, so go back and check your go back into statistics and test, and then check your values for the mu sub 0, x bar, okay, your calculator's up there. Okay.
I had these other equalities.
Okay, yeah, always use the equality for that null hypothesis. I mean, excuse me, the alternative hypothesis. All right, so any questions so far? We put everything in. We're able to pull out the test statistic, the p-value. So now we got to make like a determination. So C says the p-value, is it less than or equal to alpha, or is it greater than alpha? Right, it's greater. So we're going to compare them. So the alpha is, that was given in a problem. It was 0.002. The p-value is 0.1204. So notice that the p-value is greater than alpha. So that means we have a high p-value because it's higher than alpha, which is the significance level. So if we look back at our conditions, since we have a high p-value, we're going to fail to reject the null hypothesis. And this is just based off the low p-value, the low p-value and the high p-value. So the high p-value, we're going to fail to reject the null hypothesis. And this should be our conclusion. There is not enough evidence to support the alternative hypothesis. Okay. So let's see how that looks in the problem. All right, so for D, we're going to fail to reject the null hypothesis. and I really can't put these side by side. Okay, so if I look back at the power p-value, okay, the first thing I should read is there is not enough evidence. So as I take a look at my answer choices, A is out of the picture, right? Because A said there is. I'm looking for there is not. So B could be a possible answer choice, and D could be a possible answer choice, right? So I'm going to narrow it down even further. So there is not enough evidence to support the claim that so now this is the alternative hypothesis that the mean is less than 11. They're actually writing out. So that the correct answer here, choice here should be D. There is not enough evidence to support the null hypothesis. And they just write out the null hypothesis as what it stands for, that the claim that the population mean is less than 11. All right. So for what I wrote is there is not enough evidence to support the null hypothesis. All right. But if you actually write in what that the alternative hypothesis is, it's the claim that the population is less than 11. So any questions about number 3? So like once you put it in, once you get your test statistic, and then more importantly, once you get your p-value, compare the significance level and the p-value, and then make your determination. So we would choose D as the conclusion. All right, let's take a look at number 4. Okay. So number 4 says you're conducting a study to see if the proportion of men over 50 who regularly have their prostate examined is significantly less than 0.67. Use a significance level of 0.02. They give us the null hypothesis and the alternative hypothesis. It says that the null hypothesis is that the proportion of men over 50 who regularly have their prostate examined is 0.67. And H1, sometimes you may see the alternative hypothesis written as H. Sometimes you may see it written as H1. So here they're just kind of writing that out as H1. So it says that the proportion of men regularly having a prostate exam over 50 is less than 0.67. So notice they're giving us p-values instead of means. So I'm going to go into the calculator and I'm going to go into test. Excuse me, I'm going to go into stat. I'm going to scroll over to test. And I want number 5, the 1 proportion z-test. So this was stat, test, and this was the 1 proportion z-test. Okay. All right, so notice they only give us 2 things here. They don't give us like a hypothesized mean and then like a, hypothesized proportion, and then give us like a sample proportion. Here they just give us, you obtain a sample size of n is 749, in which there are 479 successes. What is the test statistic? What is the p-value? All right, so we're in stat test, 1 proportion z-test. I'm going to hit enter. All right. So it asks for these things. P sub 0, X, N, and then we have to put in a chest. So what do you think P sub 0 is? 0.67. That's that hypothesized proportion. Okay, just like mu sub 0 was the hypothesized mean, okay, P sub 0 is that hypothesized proportion. What is X? Remember that X is we're dealing with the proportion, so X is the number of successes, right? So that's going to be 479. N is the number of people, right? Sample, which is 749. What is our test? Are we going to use equal to, less than, or greater than? That's right, the less than, right? We always use the inequality for the alternative hypothesis. So we're going to use less than. All right. So I'm going to put that in 0.67. N is 479. Excuse me, X is 479. N is 749. And we're going to use less than. And if we calculate, right, we have the Z test statistic, which is negative 1.77. Right. So that would be A. It says, what is the test statistic? And that is negative 1.77. B says, what is the p-value? So notice you actually see two p's. Let me explain these p's. The first p is your p-value, 0.0380. The second p that you see, that's your p-hat. That means if you were to take 479, divide that by 749, that's that p-hat value. All right. That's just the population proportions estimate. Your p-value is just the p with not, that's supposed to be like a little hat over it. All right, but notice that 0.639, that actually comes from the number of successes over the total. Our p-value is 0.0380. So 0.0380. And if you look at the answer key, they have like 0.380 and then 0.0384. All right, but we're going to use 0.038. All right, so that's our p-value. So C says, is the p-value less than or equal to alpha, or is it greater than alpha? Right, it's going to be greater than, right, because our alpha value is 0.02, and then our p-value is 0.038. So that p-value is greater. Right. So if the p-value is greater, we're going to do what to the null hypothesis? Right, so let's just check. So if it's greater, Greater means a high p-value. So if it's a high p-value, we're going to fail to reject the null hypothesis. So we're going to fail to reject. And in our conclusion, I believe it's going to be D. I mean, because we're going to use there is not enough evidence. So B and D would be, we can narrow it down to B and D because they actually start there is no significant evidence. But for our purposes, the conclusions are specific, which means that there is not enough evidence to support the alternative hypothesis. And the alternative hypothesis is that the proportion of men over 50 who regularly have prostate examined is less than 0.67. So that should be D. Okay. So there are like no tricks or anything on this test. So what I mean by that is, if we go back to our conclusions, they're simply taking the start. It is there is not enough evidence to support the alternative hypothesis, and they're just writing out your alternative hypothesis. All right. So that was number 4. Okay. Any questions about number 4? All right, now the last of number 5, it deals with two means. So here's number 5. It says you're testing the claim that the mean GPA of night students is different from the mean GPA of day students. You sampled 55 night students, and their sample mean GPA was 2.51. The standard deviation was 0.38. You sampled 40 day students. The sample mean GPA was 2.29. Standard deviation was 0.6. Testing the claim at a 1% level of significance. Assume that the population standard deviations are unequal and that the GPAs are normally distributed. Give the answer to at least 4 decimal places. So now on this one, you have to write out your null hypothesis, your alternative hypothesis, okay, and then we'll kind of go through the rest of this. So we have 2 means we're dealing with. So we have the night students and we have the day students. Okay. So for each one, they give us, and I'm going to call the night students group 1 and the day students group 2. So like these little subscripts I have, X bar sub 1, that's the mean GPA of the day students. S sub X 1, that's the standard deviation for the night students. And then N sub 1, that's the sample size for the night students. And I'm going to do the same thing for group 2. So I'm going to have X bar sub 2. So that's the mean GPA of the day students. S sub X 2, right? That's the standard deviation for the day students, and also N sub 2. So I'm just going to jot in all that information. So the mean GPA of the night students was 2.51. The standard deviation was 0.38. And there were 55 night students sample. The mean GPA of day students was 2.29. The standard deviation is 0.6. And there were 40 students in that sample. So what is the null hypothesis? So remember, when you have to write them out, you always going to use equal. Right. I thought I had this on Do Not Disturb. All right. So the hypothesis, the null hypothesis is that the two groups are equal. The alternative hypothesis is that it just says that the two groups GPAs are different. It doesn't say that one is greater than or one is less than. It says that they're simply different. So for simply different, I'm going to use not equal to. So if it said like the mean of the day students was greater than the mean of the night students, you would use greater than. Or if it said like less than, you would use less than. But here it simply says is different. So that's the not equal. And that's going to be important because we use the inequality from the alternative hypothesis. We actually use that in our calculation on the calculator. Okay. So any questions about the hypotheses and how they're written out? If you have to write it out for the null, you always use equal. Now, if they write it out like they did in the previous problems, they may or may not use equal. All right, but for our purposes, when we write it out, the null is always equal. Since it says that it's different, the two means are different, we're going to use not equal to for the alternative. So now it says, based on the hypothesis, find the following: the test statistic and the p-value. So we're going to calculate those using the calculator. All right. So I'm just going to clear out my screens. I'm going to go back into stat. I'm going to scroll over to test. And here I want to use a two-sample t-test. And the reason why we're using a two-sample t-test is because we're dealing with two means. So I'm going to write that out. So we went to stat, test. This is the fourth option, two-sample t-test. All right, so I'm going to hit enter to log that in. And again, we want to use stats. So notice we got to put in all the information. X bar sub 1, that was the mean GPA of the night students. So that was 2.51. The sample standard deviation was 0.38. There were 55 students in that sample. Okay, the sample mean for the day students was 2.29. 0.6 was the standard deviation. 40 was the sample size. So now it asks for the test we're going to use. So we always use the inequality for our alternative hypothesis. So we're going to choose not equal to. Right. Okay. That's that first one. For pool, they're talking about the variance. You always choose no for pools. Now, on my calculator, I actually had to use the down arrow. I'm going to see if I can do it. So if yours looks something like this, right, and you're not seeing the rest of those options, you want to click down, right, with your cursor, and that'll bring up the rest of the options. So pooled is always no. And if we hit calculate, right, we're given the t-test statistic and the p-value. Okay. So it says, what is the test statistic? It is 2.04. Does it tell us how to round? 4 decimal places. 2.0404. The p-value is 0.0456. I'm just checking this answer key. Okay. They didn't round the test statistic to 4 value to 4 decimal places, but it says that in directions. Okay. So that's the test statistic and the p-value. So what is our decision? So I'm going to, okay, now the thing about this problem is they give you the significance level as a percent. We should change that percent to a decimal and compare decimals. Or you could change the p-value to a percent and compare the percent. So I want to let you know now, on the problems before, they gave us the significance level as a decimal. So like 1%, let me just write that as alpha. If I were to change 1% to a decimal, I would have to drop the percent, move that decimal 2 places to the left. So that's actually 0.01. The p-value is 0.0456. So the p-value is greater. So keep that in mind, because if you're just looking at this at face value, you say, well, 1 is the significant level is bigger, but you got to change that to a decimal. Okay. So that's going to be fail to reject. No. Let's see. The p-value is higher. So that's a high p-value. Yeah, so we fail to reject the null hypothesis, right? Because we're following those high p-value conditions. And what is the conclusion? Right, so if it's a high p-value, the conclusion is there is not enough evidence to support the claim.
What was the first one?
So that's going to be